and welcome back to episode number 11 of this tutorial series / crash course on ROS Noetic. You can find the series playlist in the description. And let's get started. So we're gonna start directly from the previous tutorial, okay, where we have seen what are ROS services, and actually we have started the TurtleSim node and we have called the turtle1/setPen service. Okay, this one is gonna allow us to change the color of the pen when we move the turtle. And so here, for example, we have set the color to red directly from the terminal. So now what we want to do, of course, is to call this service not from the terminal, but from our code. So you're gonna learn how to write a service client in Python. And instead of just creating a file to write a service client, we're gonna use our existing turtle controller. Okay, so let's go back to Catkin workspace source and let's open our text editor here, Visual Studio Code. In the turtle controller, what we have for now is we have one publisher and one subscriber. So we are receiving the pose, so the current position of the turtle, and from that position in the callback, we give a command velocity for linear and for angular so that we can control the turtle. So the turtle is gonna move all around this screen, this window. And so what we want to do, let's say that we want to split here the screen in two and say that when the turtle is on the right side, it is gonna use red pen, so it's gonna print in red, and when it's on the left side, it's gonna print in green. So what we want to see at the end is the trace of the turtle here. Everything here should be red, everything here should be green. And to do that, we're gonna use this service. So we're gonna create a service client. So every time we go on the other side, so on the right side or on the left side, we call the service to change the pen color. Great, so let's get started. So what are we going to do in the code? Well, the thing is, we will need to know the coordinates of the turtle. And where do we know the coordinates of the turtle for now is in the pose callback. Okay, so in the pose callback also, we are going to create a service client and call the service. So from there, what we're going to do is we're going to create another function here to call the service client, and we're going to call this function from there. And before we do that, I'm going to write one thing here. After init node, I'm going to do rospy.wait for service. So what is this? It's gonna, so this method here is gonna block here and wait for the service to be up. So if the service is not up, we're gonna continue to wait. So basically we're gonna wait for the TurtleSim node. And this is a very good practice actually, is if you're gonna use a service, you'd better make sure that the service exists, because then if you don't have the service and you try to call the service, you're gonna get an error in your code and, well, the application is not gonna work. So we're gonna first wait for the service, and I'm gonna just put that after the init node in this case. And if we go back to the terminal, what is the service we want? So let's do a ROS service list again. Okay, we want that one, turtle1 set pen. Okay, great. So that's the first thing to do. So you can either wait for service at the beginning of your node, or every time you create a client and you try to call the service. Okay, so it's up to you. And it depends, of course, on the application. And now I'm gonna create a function here, def, and let's call it very simply call set pen service. So this function is gonna be responsible to call the setPen service. And I'm gonna give some parameters here. What are gonna be the parameters? I'm simply gonna repeat the list here. So we had, so let's do this again. So ROS service info with setPen. We have this TurtleSim setPen, and then ROS srv show setPen. So in the parameters of the function, I am simply gonna repeat the different parameters we need for the request. So RGB width and off. Let's do this. RGB be with off. Okay, so now we have all the parameters and we can give them to the service client. So let's create the service client. To create a service client, I'm first gonna add a try catch structure. Okay, so actually try except in Python, because if the service doesn't work, which means that, for example, the service is not available, or you send a request that is not correctly formatted, or well, if you have a problem at the communication level, you're gonna get an exception, and you want to catch this exception. So you can do except rospy.service exception, as simple as that. And let's just put as e, and here we're just gonna do rospy.log1. Okay, this is a warning, depends on if it's a problem for your application or not. You can put warning or error, and then you can eventually fix something here, and let's print e. So if the service doesn't work, the service call doesn't work, we're gonna get an exception, we catch the exception, and we just print for now with log1. Okay, and to create the service, I'm gonna say set pen is equal to rospy.service proxy. Okay, that's how you create a service client, with rospy.service proxy, and you need to give the name of the service. So we already have the name here, and also the type. So the same as for a publisher or subscriber, you have a type for the service. If we go back here to the terminal, you can see, well, actually the type is TurtleSim setPen, which contains a setPen request and a setPen response. So we will need to import setPen from TurtleSim. Let's go back to the code. We do from TurtleSim dot, and here we're not gonna use MSG, we are going to use SRV because we want a service. Okay, so MSG for messages for topics and SRV for services. Import setPen. As you can see, we have setPen, setPen request, and setPen responses, which are inside the setPen service. setPen. Okay, and when we have this, we actually have the service client here, and we can directly call it. So this is kind of a function. We can directly do setPen from what we have received here from the service proxy, and then open close parentheses, and we can directly pass the arguments for the request. And so the request here, you can see RGB width off. So those are the arguments you can send, and that's exactly what we're gonna do. We're gonna send the arguments here that we have passed in the function. RGB width off with the correct order. Okay, that's very important. Okay, so you create here the service client, then you call, and what you're gonna get here with that is a response actually. So the response is this. And then what you can do is, for example, rospy. So you can process this response. Okay, if you are calling the add to ints service, you will get the sum, and maybe you want to do something with the sum. Okay, here, well, let's just do log info with response. You can just also print the response if you want to. And what's going to be the response? Well, actually, we don't have any response. So I'm just gonna comment this, okay, just to show you that you can print the response if you want, but I'm just gonna comment it for now because anyway, it's not gonna do anything. And well, the function to call the service is finished. So this may seem a little bit complicated, but well, actually, once you've done it once, this is gonna be the same every time, okay? You use a try except structure with rospy service exception, and then you use a rospy.service proxy with the name of the service, the type of the service. You get the function to call here, and then you just call it and you pass all the parameters of the service request. You get the response, and then you can process the response. And so what I'm gonna do first, I'm not gonna directly use it in the pause callback. I'm just gonna make a very quick test to make sure it is working. So I'm just gonna call the function here after wait for service, because now we know the service is up, so we can call it. So call set pen service, and let's try to put it let's try to put it red. So with 255, for example, 0, and then blue is gonna be 0 with, okay, we can't put 0, otherwise it's not gonna print anything. So let's put 3 and then off 0. Okay, let's save this. So we're gonna initialize the node, wait for the service, call the service, and then do the closed loop control with the publisher and subscriber. Okay, let's do this. We have the turtle sim here. Let's keep it, and let's do the ROS run my robot controller turtle controller. Okay, as you can see here, now it is red. So we have the closed loop system, but the pen is red. So what we can say is that the service is working. Now I'm gonna remove this. So one very best practice with ROS is to test everything as soon as you do it, okay? You have a callback, you make sure that the callback is working, and then the publisher, you make sure you can publish, and then you combine the two together, and then you create a service, etc. And this way, well, ROS development should not be that hard. Now let's add some logic. So what we want to do is to say that here, when we pass, when we are in this zone, so x is gonna be greater than 5.5, okay, because the minimum is 0, the maximum is 11. So if x is greater than 5.5, we want the color to be red, I think, and on this side we want the color to be green. So in the pause callback here, so we first create a comment and we publish the comment, and after that I'm gonna do if pause.x is greater, let's say greater or equal than 5.5, I'm gonna do call set pen service with 255, 0, 0, 3, and 0, and then else call set pen service with this time 0, 255 for green, 0, and then width 3 and 0. So in this callback we do two things. Okay, we publish on a topic and we call a service. Now I'm not gonna run the code like this, because if we leave it like this, the problem is that we're gonna call the service very frequently. So with a publisher, that's not a problem. You can publish at a very high frequency, let's say a few hundred hertz. Even you have some controllers that publish at 1000 or 2000 hertz. But for a service is not made for this. A service is not made to be called 100 times per second. Okay, service is made to be called from time to time when you need to call the service. And well, I'm gonna show you something very quickly here. So we have the turtle sim node running, and let's do, well, actually let's go here. If I do ROS topic list, so we have the pause topic. Okay, so basically the callback here is gonna be called every time a message arrives on this topic. And there is a new command you can use, is ROS topic HZ, okay, for hertz. Basically it's gonna give you the frequency, so the publishing frequency on one specific topic. And so if you do that, it's gonna subscribe to the topic and it's gonna print the average rate. Okay, so let's leave it a few seconds and Control C. You can see the average rate right now is 58 hertz, which means 58 messages per second. So this callback right here is gonna be called 58 times per second. Okay, which is not a problem, and you're gonna publish at 58 hertz, which is not a problem. But calling a service at 58 hertz is gonna be a problem, and it's probably gonna slow down your application. Okay, this should be called when you need it, not 50 times per second. And so why I say that is because we can actually improve the code to say that we can change the color, so we can actually call the service just when we go from left side to right side and from right side to left side. Not every time we move the turtle, okay? Because if it's red here, it's gonna be red here and red here and red here, okay? So it's gonna stay red, so we don't need to modify every time, okay? So what I'm gonna do is I'm simply gonna compare the current X coordinate with the previous one. So I'm gonna create here a global variable. I'm gonna name it, let's say previous X, and well, let's just say it's 0, okay? And then here, because it's a global variable and I'm gonna modify it, I'm gonna do global previous X, and I'm gonna say that I'm gonna use the call setPen service with a red color only if we go from lower than 5.5 to greater than 5.5. So if the pose is greater than 5.5 and the previous pose, so the previous X was strictly lower than 5.5, in this case we can call the service. And of course we are also going to update, so previous X is equal to pose.x. So every time we receive a pose, we compare it and we also save the previous pose to be the current one, so that the next time the current one is gonna be the previous one. And maybe let's just put rospy.loginfo set color to red, okay? So we can even know from our own node when we change the color. And then else, well, that's not gonna be an else, that's gonna be an else if pose dot x, and let's say strictly lower than 5.5 and previous x greater or equal than 5.5. So if the previous x was on the right side and now we are on the left side, just at this point we're gonna call this to change the color to green. And we're also gonna do previous x is equal to pose.x. And why not do rospy.loginfo set color to green. Actually this, we don't even need to put it there, we can just update this after the if, okay, like that. Okay, so what do we do here? We check what we get, so the current pose, the current X coordinate, and we compare to the previous one. And every time at the end, we update the previous one to be the current one, so that we only change the color when actually we cross the middle line, okay, from right to left or from left to right. And let's actually try this code right now, okay? You can see the post callback is a little bit bigger now, and we first have a publishing functionality and then a service client. Let's save the file, let's go back to the terminal, and let's just run. So I'm gonna start with a clean turtle. Still have the ROS master running here, and then clear, and let's do ROS run my robot controller, turtle controller. Let's see what we have. Okay, set color to red, and then set color to green, set color to red. Okay, it's working. So let's leave it like this for a few seconds or a few minutes. I'm gonna go faster with the video to show you what we can get. Well, it seems that our turtle is having fun, and we can see clearly here a separation. So on the right side we have everything red, on the left side everything green. Okay, great! You have successfully combined publishers, subscribers and services in the same node, and just about here 44 lines of code, and we have a lot of ROS functionalities already. Congratulations! Hey, it's Edward. I hope you enjoyed this crash course and that you found it useful. Now, if you want to continue to learn ROS with a full and in-depth course covering everything about the ROS concept, Python and C++ code, and more practice activities, well, I have the course just for you named ROS for Beginners. This course contains 6 hours of structured video content, and also you can download the code for each activity. You will dive into the ROS concepts with much more details and also discover ROS parameters, launch files, how to write service servers, and many other things. So if you like the way I teach, I recommend that you check the course out. The link is in the video description. Click on the link, read the course description, and decide if you want to continue. Also, the course will be updated if anything changes in the future, so don't worry about that. I also have another complete course to learn ROS2 named ROS2 for Beginners. This one contains more than 11 hours of video content with a big final project to practice even more, and again, the link is in the description. And now maybe just one question you might have is it still worth it learning ROS1 today because of ROS2 is kind of taking over? And well, that's a really good question. The first quick answer I would give is the best is to learn both ROS1 and ROS2. And the second answer is it depends on when you see this. Because when I publish this video on YouTube, well, it's not a secret, you can actually see the published date. It is early 2022. ROS Noetic will be supported until May 2025, at least that's the official date they have announced. And now the reality is that even if ROS2 is more and more used, ROS1 is still currently used in many companies for many robotics projects. And some projects are huge, and for some of those it's probable that ROS1 will be used even after it is not supported anymore. I mean, you still have airports running Windows 3.1 even today. So my guess is that ROS1 will fade away, but maybe not completely disappear. And we might see some community projects popping up around 2025 to continue maintaining a ROS1 stack. Well, this is just some theory, right? I of course can't predict the future, but this prediction is just to tell you that knowing ROS1 will probably still be relevant even after its end of life in 2025. So what to do? Well, you might learn ROS1 specifically to prepare yourself to work on legacy projects. Because if you get hired, for example, well, you're gonna arrive in the middle of existing projects, and if they are using ROS1, well, you will have to use ROS1. So that could be a competitive advantage for you. Then if you see this and we are still in 2022, 23 or close to that, well, at this point it's possible that not everything you need has been ported to ROS2, and in this case you will need ROS1 for a few functionalities. And also, as a general advice, learning ROS1 and then ROS2, or learning ROS2 and then ROS1, or at the same time, will allow you to better understand the ROS ecosystem, that's for sure. Alright, thank you for watching, and I hope to see you in my ROS courses.